Hello programmers. Today this is going to be the next tutorial in the Coder's Basilisk Advanced tutorial series. We're currently talking about advanced metaprogramming. This is new computer science we're covering, guys. New computer science. So anyway, this is bldr.hbas, right? As I talk about this, I'm going to expect you to be intimately familiar with reflect.hbas. You should be intimately familiar with how this works. And the reflection library. You also need to be familiar with the overall structure of the main compiler, of the process of files being tokenized, parsed, parse hooks being invoked, and then codegen main being invoked. You should be familiar with that. Down to not minute detail, but at least high-level detail, right? In this tutorial today, we're going to be talking about the builder abstraction. In this, and it's basically defined in this slightly over 1,000 line file, and in this file we basically iteratively define new constructs as we go throughout the file. The very first thing defined here is the builder namespace, and basically what this is it is just a way of taking one set of identifiers and then turning it into another, right? At X becomes at CG_BLDR_X, right? And that's basically what's being done here, right? This is the builder at BLDR right here. The way that this thing works is it basically just, accesses CG peak. It, grabs an argument list. Then it creates two functions. One of them is something that literally contains your code right here. Right here, this thing. And then the other one is the thing which is the wrapper, right? And the wrapper basically is what grabs the argument list to your main function, right? What the builder does is it formalizes the abstraction of let's scroll down. It formalizes this interface at name, open square bracket, tokens in here, right? This interface, right? So name is the name of your builder, right? So what you would do is define at builder name code to implement name. Yeah. So you do this, and then you do this, and that's what BLDR does. Anyway, let's Control Z that so it's not in the history. BLDR in. Scroll down here. Builder in. What this does is it allows not just one bracketed argument list, but multiple, right? So if we builder in, I believe it's used down here somewhere, right here. Builder in. What it does is you do at builder in, and then the name, some name here, an integer, followed by this, right? The difference between BLDR and between BLDR and MakeBuilder and BLDR in and MakeBuilder in is the basically the use of the namespace. MakeBuilder and MakeBuilder in use the namespace. Meanwhile, the original things do not. If you scroll through here, there will be nothing about the namespace inside of the original BLDR, right? So, oh, wait a minute. Isn't there? Oh, no, right. It's the actual replacement of token. Things get added to the namespace from BLDR and BLDRN, but they're, the place where you actually do the replacements is right here, right? Replacing happens here. BLDRN, by the way, here is defined right here, and you'll see that MakeBuilderN is defined right here, and if you look here, it goes through the argument list, and it looks through the builder name. It looks through the namespace, and if there is an entry, it does the replacement. So yeah, right. And I hope I don't need to explain too much of how this works. you should be familiar. You should be able to. It's quite lengthy and kind of ugly looking code, but it's very obvious. All it's doing is it's just accepting a sequence of tokens enclosed in square brackets. Like this thing here, all it does is it accepts a sequence of tokens enclosed in square brackets off of the main token list, and then defines two functions. Okay, that's all it does. That's all it does. And then it pushes onto the token stream right here. Same with this thing. This does like the exact same thing, except the semantics of one of the functions is different. And make builder and make builder n, they're basically just wrappers that implement the namespace. Okay, and for the rest of the file, what I'm going to be doing here is defining a whole bunch of basically itty-bitty little helpers that I use in writing builders. Let's scroll down here. Dupe.ll inlist, for instance, right? Dupe.ll inlist takes the inlist inlist, by the way, is the name of the argument to the function defined by the inner function defined by the @builder, right? The inlist or builder n, right? And so what this does is it just defines inlist dupe as a variable that just takes the inlist and then duplicates it. And then this thing is the same thing, but it's calls dupe instead of dupe.ll, which if I recall, I don't recall what the difference is. So let's check. I actually don't remember. Built-in Sterl dupe. Let's okay, yeah, so this just duplicates a single token, right? So this duplicates the single token at the so it won't duplicate the entire linked list, it'll just duplicate the single token, right? So that's what this is doing. It's taking the inlist and then taking the very first token from off of the front head of the list and then duplicating it. This right here, push qtoke, is just going to take qtoke, then push it onto the end of the onto whatever list is currently being pointed to by rwalk, which is a function I very frequently use inside of my builders, right? Init qtoke, this defines retval and rwalk, right? And so basically this is how you begin constructing the output of a no decal will not declare these two variables. That's in case they're already defined. Init vars, this just defines these variables. Dummy, I don't remember what dummy does. Oh, and then init qtoke inserts. So init qtokes from a string with a pound sign. Okay, that's very strange. Oh, that's right. And very often I use a dummy head, right? And this basically defines a dummy head token, right? Dummy var, right? So this dummy, right? So instead of explicitly having a dummy token that's fully allocated and stuff, we define a dummy token explicitly right here. And as you can see now, we're actually using we go from doing this stuff to using push qtoke. Then we're using init qtoke, init qtoke, push qtoke, and you can hopefully see here how this works, right? So this interface becomes very, very clean as we scroll down the file, right? And this, by the way, is a good proof of how metaprogramming works, right? I know these are basically just macros right now, but in principle, what you do is you're basically building a series of tools as you go down the file that make your programming cleaner and easier to read. This is pretty easy to read, and it doesn't take very much thought or effort to figure out what this is doing. And if you scroll down the file, again, these are should be fairly obvious once you have the vague structure of how these works. So these are just variables being defined inside this inside of a function, right? And this is, by the way, is a very beautiful file in my opinion, right? It's a file that clearly and quickly shows how how you do metaprogramming, right? This is a good showcase of how metaprogramming makes your code easier, your programming easier to do in a very simple way, right? Again, these are mostly just macros, but this is a good example of how it can work. And this is basically the last thing defining the file. rwalk skip, right? Basically I think it just formalizes this, right? It even inserts this cast here. We don't technically need this. I could delete this. I might push an update which removes this cast. But anyway, and it basically just skips rwalk to the end of the linked list. Anyway, so that's the builder library. In the next tutorial, we're going to be talking about worksheet, which is a shorter file, mostly because of the stuff we did in builder, right? And what worksheet does is it basically just replicates and extends upon the so that's actually the correct syntax right there. What this does is it basically replaces C's pound to define with arguments. This is going to be the next tutorial. Anyway, I hope you guys enjoyed. Thanks for watching.